Hey guys, it's Peyton. Let's look at solving rational functions. Let's take a quick look at a rational function to remind ourselves. The most common one is y equals 1 divided by x, where the independent variable, here it's x, is in the denominator of some function. The trick with these is sometimes the algebra is a bit hairy. Let's work through some examples using multiple methods. First, we're going to approach the concept algebraically. The basic method is do the necessary algebra so that there are no x variables in the denominator of any fraction, and then we solve for x. Here's an example. 1 is equal to 4 divided by x squared plus 5 divided by 9. The first thing we should do to isolate x is to subtract 5/9 from both sides of the equation. And so it becomes 1 minus 5 divided by 9 is equal to 4 divided by x squared. I'm going to simplify that just a little bit, and 1 minus 5/9 is equal to 4/9. And so now the equation becomes 4/9 is equal to 4 divided by x squared. Now we want to isolate x, so I'm going to multiply both sides of the equation by x squared. And our equation now becomes x squared times 4 divided by 9 is equal to 4. To further isolate x, we'll multiply each side by 9 divided by 4. And so it becomes x squared is equal to 4 times 9 divided by 4. Okay, I'm going to simplify the right side of the equation. 4 times 9 divided by 4 is just going to be 9, so it's x squared is equal to 9. And I'll solve for x here by taking the square root, and therefore x will equal plus or minus 3. That was an easy example. Now let's look at a little bit of a tougher one. 13 is equal to x divided by the quantity x plus 4 plus 4. This one has both an x in the numerator and denominator of a fraction, which at some times can make things difficult. Let's see what this one holds for us. First, we want to work at getting x plus 4 out of the denominator by subtracting 4 from each side. So we will have 13 minus 4 is equal to x divided by the quantity x plus 4. 13 minus 4 is 9, so it becomes 9 is equal to x divided by x plus 4. Now we multiply each side of the equation by x plus 4 to get rid of that denominator. So the equation becomes 9 times the quantity x plus 4 is equal to x. And I'm going to distribute that 9 across that quantity, so it becomes 9x plus 36 is equal to x. Here I will subtract 9x from each side of the equation, and then we can solve for x. So it becomes 36 is equal to x minus 9x, which simplifies down to 36 is equal to negative 8x. Now we divide by negative 8, and we'll find that x is equal to negative 9/2. Okay, that one's a little challenging. Let's try one more. 1 is equal to negative 2 divided by the quantity x squared plus 4x plus 2 minus 1. First, let's add 1 to each side. And so the equation becomes 2 is equal to negative 2 divided by x squared plus 4x plus 2. Now to continue isolating x, and to lose the fraction, we will multiply by x squared plus 4x plus 2. So the equation now becomes 2 times the quantity x squared plus 4x plus 2 is equal to negative 2. Here we can go either one of two ways. One, we can distribute the 2 across the quadratic and then simplify after there, or we can divide both sides by 2 and simplify. I prefer to divide by 2 because the algebra is a bit easier. And so dividing by 2, the equation now becomes x squared plus 4x plus 2 is equal to negative 1. To further simplify the equation, I'm going to add 1 to both sides. So it becomes x squared plus 4x plus 2 plus 1 is equal to 0. And 2 plus 1 is 3, so the equation now becomes x squared plus 4x plus 3 equals 0. Finally, we have a quadratic we can solve. We can either use the factoring method or the quadratic equation. This quadratic is factorable, and the factors are the quantity x plus 1 times the quantity x plus 3 equals 0. Solving for each binomial, we'll have x plus 1 is equal to 0, which gets the solution x is equal to negative 1. And the other is x plus 3 equals 0, and so the solution is x equals negative 3. Okie dokie. Let's formulate a basic way of approaching the rational equations algebraically. Perform the necessary algebra to make sure there are no fractions, then solve for x by the appropriate methods. Now, let's look at solving these problems graphically. For the following graph, determine for what x value does y equal 6. Looking at the graph, we go to where y equals 6 and see what x values correspond to it. Here there are two solutions. One is easy to read off, when x equals 4. The other is up to our ability to approximate solutions. I say the other solution is x equals a half. Let's look at another example. What is the value of f of 2 for the given graph? Looking at the graph, we see that the value of f of 2 is about 5. Let's look at a real-world example using rational functions. The force between two objects due to gravity is given by the equation F is equal to capital G times m sub 1 times m sub 2 divided by r squared, where G is a universal gravitational constant, m1 and m2 are the masses of two objects, and r is the distance between these objects. Let's work an example. If the force due to gravity between a person having a mass of 150 kilograms and a pencil having a mass of 0.01 kilograms is 40 newtons, what is the distance between the person and the pencil? G is equal to 6.67 times 10 to the negative 11th newtons times meters squared divided by kilograms squared. Don't worry, it's just scary looking. Okay, now we just need to plug the information to our equation and determine the distance. So this is what our equation looks like. 40 is equal to that really scary gravitational number, 6.67 times 10 to the negative 11th, times 150 times 0.01 divided by r squared. Now to solve for r, I'm going to multiply both sides of the equation by r squared, and then I'm going to divide each side of the equation by 40. And here's what I have. R squared is equal to that really scary number, 6.67 times 10 to the negative 11th, times 150 times 0.01 divided by 40. Now I'm going to simplify the right side of the equation, and that ugly mess turns out to be 2.5 times 10 to the negative 12th. Now let's take the square root of both sides, and we find that r is equal to 1.58 times 10 to the negative 6 meters. So the distance for there to be 40 newtons of force between a person and a pencil is really, really, really small. 1.58 times 10 to the negative 6 meters to be exact. Let's look at another example. The equation to find the image distance of an object from a mirror is given by the equation 1 divided by p plus 1 divided by q is equal to 1 divided by f, where p is the distance from the mirror the object is, q is the image distance from the mirror, and f is the focal length of the mirror. Find the distance of an object from a mirror when the image distance is 5 feet and the focal length is 3 feet. We have to find p. So let's input our information into the equation and begin solving. So the equation becomes 1 divided by p plus 1 divided by 5 is equal to 1 divided by 3. Now we solve for p. First, let's subtract 1/5 from each side. So it becomes 1 divided by p is equal to 1 divided by 3 minus 1 divided by 5. And I'm going to simplify that just a bit. So it becomes 1 divided by p is equal to 2 divided by 15. Now let's multiply each side of the equation by p and each side of the equation by 15 divided by 2. So we can have p by itself. And we'll find that p is equal to 15 divided by 2, or p is equal to 7.5. So we find that an object has to be 7.5 feet away from a mirror with a focal length of 3 feet to create an image distance of 5 feet. Pretty cool, huh? Solving rational functions isn't hard. Using a graph is pretty easy. Solving them algebraically can be hairy, but it's manageable. Just remember to get rid of those mean fractions. I'll catch y'all next time. See you later.